And as you see in the middle, there is a pressure. The pressure is causing the two inner field lines to get closer and closer together. So it's putting a lot of pressure on this central boundary, and the pressure can cause an inflow. So this is just like you say the current sheet is like a plastic pipe. You just putting your fingers either side of the pipe, like either side of its diameter, and like just pressing in, like rather like a hose pipe. So when you have a hose pipe, if you press on the hose pipe, the pressure becomes like the pressure of the water increases. It's a bit like that. So you're pressing quite similar to that. So it presses like that, and it causes an inflow. Now, as that inflow occurs, mass, obviously, this isn't like a hose pipe. It's not just shooting particles out. It's just a sheet that's stopping these from reconnecting. So as the inflow is occurring, mass from that was in the point of the inflow is pushed to either side, so that obviously the inflow isn't overdense. So it's pushed to either side, which causes that inflow to become weaker and weaker and weaker. And as it becomes weaker, the magnetic attraction of the two opposite poled magnetic forces, because obviously these two parts of the magnetotail, the top and the bottom, one of them's got a north terrestrial pole and a south terrestrial pole, so they're magnetically they are opposite, so they want to attract. So this current sheet prevents that, but as this point becomes weaker, that obviously overcomes this magnetic attraction and finishes this process known as magnetic reconnection, and the two field lines reconnect. So obviously it causes an inflow, this inflow becomes weaker, and the two field lines reconnect. And this obviously causes the new field line, causes a new field line. Now, on this animation, I'd like to point out at the very start, it will be very hard to see. It might take you a few times to see it. You might want to go back. But at the very start, the inflow is happening, and then the right hand side, there is a part of the magnetic field, the field lines, which goes out into space. This is obviously just plasma being ejected from this interaction, and the other ones form this magnetic field line. But obviously all those particles that were in that long field line can't suddenly sit in this one, so they shoot down the field line by the force from this interaction of the two magnetic poles coming together. One of them is attracted to the north, so they shoot to the north, and one of them is attracted to south, so they shoot to the south. And these charged particles, which are shooting down the field lines, come into the ionosphere, give energy due to, collisional excitation to they collide with the nitrogen and oxygen in the ionosphere, which is a high part of our atmosphere, and this causes the particles to be energized, and to get rid of this energy that they have now received, they go back to their normal state and release photons, which is light, and this is the aurora. So I've already explained the events leading up to the aurora, as the charged particles that form the field line now shoot down the new field lines. Because of the magnetic reconnection, they have a force, and magnetic fields have a force which is perpendicular to their plane, while electric fields force parallel to their plane. So these charged particles now have two forces shooting them down the field line, and they move in a helix motion around the field line as they shoot down. Just an interesting fact. So thank you for watching, and these are in fact the events leading up to Aurora. And thank you very much for watching. I hope you enjoyed. I hope you've learnt more about how the Aurora occurs, because my reason for doing this, and doing this as a YouTube video, trying to teach people how the Aurora happens, because I was trying to find out how the Aurora happened, and a lot of it was explained wrong. It was just straight wrong, because it's claimed that particles from the solar wind just went in the gaps of the magnetic field and shot down into the ionosphere. It's not. It's caused by the magnetic field. So I hope this teaches you a bit more about how the aurora happens, and I thank Laura for these images, which are unedited, by the way, so I think they are really, really cool images. Thank you very much for watching, and bye-bye.